In this lecture, we're going to talk about some evidence of chemical reactions, so how we know chemical reactions are taking place, as well as how to classify some chemical reactions, mainly noting the terms like decomposition, synthesis, single replacement, and double replacement reactions. All right, so as we know, chemical reactions take place all around us and even inside of us. They produce changes in the arrangement of molecules and atoms that compose matter. So during a chemical reaction, the reactants or the starting ingredients break apart and their atoms reform into new things, and we call those products. So these molecular changes cause macroscopic changes that we can see directly and experience. So for example, in the classic vinegar and baking soda experiment, where we've got vinegar and baking soda volcanoes, we can, directly see that there's bubbles and foaming happening when those vinegar and baking soda molecules rearrange themselves. Similarly, in a car engine, we have the combustion of fuel with oxygen, and that leads to a combustion reaction where energy is let off, and that energy is then used to power vehicles. So let's take a look at some evidences of chemical reactions. All right, so when chemical reactions occur, a lot of them produce easily detectable changes that we can see. So for example, color change. So if there's a change in color, then a chemical reaction likely took place. If we have a formation of a solid, we call that precipitation. So over here on the right over here, we've got, this cloudy yellow stuff forming when these two liquids combine. We call that precipitation. The formation of gas bubbles. Okay, so like in this one over here, we've got the formation of gas bubbles in that test tube is also an indicator that a chemical reaction has occurred. Heat absorption or emission, so if something feels hot or something feels cold than before, so for example, this ice pack is an example of a chemical reaction that's going on inside of the bag that is making it feel cold, because it's absorbing the energy away from you. And then last but not least, light emission. So the classic glow sticks are also a chemical reaction. In fact, you've got to break the tube inside of the tube, right? And when that happens, then the two chemicals mix and create light. So those are some things that we're going to look for when we're mixing chemicals together to see if a reaction actually occurs. All right, we do need to be careful sometimes in figuring out if a chemical reaction occurs, because some of these changes are also evident of physical changes and not necessarily chemical changes. So some of these are not definitive pieces of evidence. So for example, we've got here water boiling and bubbles are being made. Okay, but this is not a chemical reaction. This is a physical change of state, right? Going from a liquid to a gas at the boiling point or evaporation point. And that is a phase change, which is physical. It's still water as a liquid and still water as a gas. So we're not being, rearranging anything in that particular case. So we do need to be careful with bubbles and figuring out whether those bubbles come from a mixture of two substances or whether these bubbles are from heat because that substance got to its boiling point. Okay. So we do have to remember that changes that occur at the atomic and molecular level are the ones that are going to determine whether a chemical reaction takes place. So in this picture here, okay, the actual chemical reaction that's taking place is in the burner underneath. Okay, in the burner underneath, we're having the combustion of methane gas with oxygen gas to make carbon dioxide and water. All right, so we have the production of light and heat, which are evidences of chemical reactions. But the bubbles in the water, not a chemical reaction, that's just a phase change. All right, so I want you guys to take a few minutes to look at these examples and kind of figure out whether you think these are chemical reactions happening or not. So the first one is ice melting upon warming. The second is the electric current passing through water, resulting in the formation of hydrogen and oxygen gas that appear. So you can see the little bubbles inside the test tubes. Okay. The third one is iron rusting. And the fourth one is bubbles forming when the soda can is opened. All right, so there's two that are chemical reactions. Okay, and it's these middle two. These middle two are rearranging atoms in order to make something new. So in the water, we're passing electrical current that is literally breaking apart water and forming hydrogen and oxygen gas. And then the second one, the rusting of iron, iron is reacting with oxygen in the air to make this new brittle orange substance that we call rust. And it has its own characteristics that is different than the iron and the oxygen that we started with. Okay. So the other two, ice melting, is not a chemical reaction. That is just a phase change going from a solid to a liquid. Okay. And then also the can of soda being opened is not a chemical reaction as well. That's just the escape of the carbon dioxide from the soda. And if it happens violently, then yes, it will take some of the soda with it, making that foam. But again, this is not a chemical reaction, just a phase change or a letting of those gas molecules out of its trapped container. All right, so now that we've taken a look at some evidences of chemical reactions, let's take a look at classifying chemical reactions. So mentioned in our other lecture last week that there are different ways to classify the types of chemical reactions. We can either take a look at the kinds of reactants or products that are involved. That's what we took a look at last week when we talked about acid-base reactions, precipitation reactions, gas evolution reactions, combustion reactions. Okay, those are the kinds of reactants or products involved. And then the second way that we can classify types of chemical reactions is by what the atoms are actually doing. And that's what we're going to talk about today. So these types of chemical reactions, taking a look and seeing what atoms are doing, okay, involve these four here: combination, which we also call synthesis, decomposition, single replacement, and double replacement. Okay, so these focus on patterns of what's happening with the actual elements and atoms themselves. So the first one we're going to take a look at is synthesis or combination reactions. And in these types of reactions, we have simple substances combining to form more complex substances. So there are going to be two or more reactants on the left-hand side of the arrow coming together to form one big product in the end. Okay, so two or more coming together to form one big product. So the general kind of way we represent that is A plus B reacts to form C. So we have two things to start and one big thing in the end. So that, again, we call that synthesis or combination reactions. So a classic example is this down here. We've got chlorine gas and sodium metal. When we put the gas or the metal inside of a gas a tube with the gas in it, we get a violent reaction. All right, and in the end, we get sodium chloride, which is that salt that we use to flavor things. Now, the opposite of the opposite of combination reactions is decomposition reactions. So in the last one, we saw that the synthesis or combination reactions are taking two or more reactants and making one product. In this case, in decomposition, we are going to be taking one reactant and splitting it apart into two or more products. So here we've got one reactant here, and we've got two or more products being made on the right. So the classic or, kind of general scheme is this. We have AB starting together, and that breaks apart into atom A and atom B separated. Okay. Typically, decomposition reactions are going to require energy in the form of heat or electrical current or light to make them happen. So we need to add energy in order to break apart the atoms and the molecules to start with. So a lot of times these decomposition reactions require some kind of energy source to get them going. So they're not typically spontaneous reactions. The next type of chemical reaction that we are going to talk about is single displacement or single replacement. You might see both referred to. Okay, I typically say replacement, but your textbook says displacement, but it means the same thing. Okay, single replacement or single displacement. So in this one, we have one element. Okay, so we always start with something that is single or alone. And then we also have a compound as well. Okay, so in this one, we have a single element and a compound, and this element is going to replace one of the atoms in the compound. So for example, this first one, zinc, since he's a metal, he's going to kick out the other metal atom, and we're going to get zinc chloride in the end, and that poor copper guy gets left by himself. Okay, so single replacement, we have a single element replacing one in a compound. So we have a new single element in the end. Same thing that happens in the next one. We've got sodium, and that's single. And this sodium is going to, he's a metal, so he's going to replace the metal acting hydrogen in this one to make NaOH, and then that hydrogen is going to be kicked out to make hydrogen gas. So in a simplified kind of generic way, we say A plus BC reacts to form AC plus B. So A here is kicking out B, so B's by itself, okay, and then AC form a new compound in the end. Okay, so this is an example of one. We have copper wire in a solution of, I believe, silver nitrate, and we're going to get silver getting kicked out. So silver is going to start forming on this wire here in this solution. All right, next one is called double displacement, or again, double replacement reactions. And in this one, we are going to start with two compounds. So here we've got two compounds as reactants. Okay, and basically what they're going to do is they're going to switch partners. So for example, in this first one, silver is going to break away from nitrate, sodium is going to break away from chlorine, and they're going to switch places. So in the end, we have silver, instead of being hooked up with nitrate, is going to be hooked up with chlorine for silver chloride. And sodium, instead of being hooked up with chlorine, is going to be hooked up with nitrate to make sodium nitrate. So when they switch partners like that, that's what we call double replacement reactions. So again, here is the general kind of formula. We have compound AB and compound CD reacting to form compound AD and compound CB, where we've got the A and the C's switching places. So A and D go together and C and B go together. All right, so the last slide here is for you guys to try kind of looking at chemical reactions and figuring out whether these are synthesis, decomposition, single replacement, or double replacement. So the first one, we've got two reactants making one product in the end. And so that is what we call synthesis, right? So we have two things and it makes one giant thing. We call that synthesis. The second one is compound and a compound making different compounds. Okay, and we can see that, for example, barium is switching partners or switching places with potassium. So instead of barium nitrate, we have barium sulfate as a product, and then potassium, right, who was with sulfate to start, is now with nitrate in the end. So we call this one a double replacement. Good. All right, the next one, we have a single aluminum and a compound iron oxide. And we're going to end up with iron by itself, and aluminum oxide is the product. So this is a single element and a compound, so we call this single replacement. Okay. All right, next one, we've got one single reactant forming two products. So a single thing being broken down into something else is decomposition. And then last but not least, we have two reactants making a single product. So they're coming together, like combining. So that's combination, or what we call synthesis reactions. Okay. So there's multiple ways to classify chemical reactions. We can do that by what the atoms are doing, like in these examples here, or we can do it by what kind of phenomena that we see taking place, like gas bubbles and precipitation and acid-base neutralization reactions and all that jazz like we saw last week. So in our lab next class, we're going to be witnessing a bunch of single replacement reactions in lab number 6. And then in lab number 7, we're going to be taking a look at double replacement reactions.